There are two reactions that you can use to produce ethanol. The first is fermentation, the second is hydration of ethene. This video is for both GCSE and A-level students. Let's go. So first and foremost, we're going to start off by hydration of ethene. This requires extremely intense conditions, but it gives a higher yield and a higher rate of reaction. Let's go. So you need 60 atmospheres pressure and 300 degrees Celsius. I've color-coded it, so all the good things about this reaction are in green. All the bad things about this reaction are in red. So, let's go. Another good thing about this reaction is that it has a 100% atom economy. What that means is that all of the reactant molecules are converted into the product molecules. So any wastage that happens in this reaction is purely because of a low percentage yield. Okay, fair enough. Now let's look at the mechanism. So the mechanism is very simple. The rich area of electron density is obviously the carbon-carbon double bond. This is attracted to the phosphoric acid H plus proton, okay, because we have phosphoric acid as the catalyst. And then what happens is essentially the double bond opens up and we form a carbocation intermediate. Once we form this carbocation intermediate, we react it with steam. Now, it's very fundamental that you remember that it's steam, not water, steam, like gas. Water, but gas. Steam. Okay, glad we've got that hurdle out of the way. Now you react with steam, you get H2O attached, the O becomes positive, and you draw an arrow from one of the H's to the O, bam, you have your ethanol. Okay, that's reaction number one. Reaction number two is fermentation. You have yeast as the catalyst, and you have anaerobic conditions, 37 degrees, so room temperature, and then you form CO2 and the ethanol. So it's not 100% atom economy, so that means that there is more wastage. It's also slower and has a lower rate of reaction. However, it doesn't cost as much to get those high pressure and high temperature conditions that you need for the hydration of ethene. Okay, and the conditions are 37 degrees, anaerobic, and you need yeast and a sugar obviously because that's the reactant.